You know that feeling, right? You've baked a batch of cookies and they're good, but they're not perfect. And you're left wondering, was it the flour? A little too much sugar? Maybe 2 more minutes in the oven? Well, today we're going to talk about a scientific method that takes all that guesswork and turns it into a clear formula for success.
So let's just dive right in with that classic challenge, baking the absolute perfect chocolate chip cookie. What does that even mean? Is it chewy, crispy, somewhere in between? And seriously, how on earth do you even start to figure that out systematically?
Because all of a sudden, you're not just a baker, you're a food scientist. You've got all these variables. Do you use bread flour for more chew or just all purpose? Is it the brown sugar giving you that deep flavor or do you need more white sugar for the crispiness? 10 minutes? 12 minutes? The list just goes on, and trying to test every single one of these one by one, you'd be baking for weeks.
Now, the way most of us would do it is, methodical, but honestly, it's pretty flawed. You bake a batch, then you change just one thing, say the sugar, and bake it again. Then you tweak just the baking time. It's so slow, it's like watching paint dry. But the real problem, the huge problem, is that this method can totally miss the secret. What if the magic isn't in one single ingredient, but in the combination of them? This is where we get off that slow, frustrating path and take a much, much smarter route. It's a system called design of experiments, or just DOE for short. Honestly, you can think of it like a GPS for finding the perfect result. It doesn't just show you the roads, it shows you how they all connect to get you to your destination way faster. The legendary statistician George Box, who was a real giant in this field, he put it perfectly. He said, all experiments are designed experiments. Some are poorly designed, some are well designed. What he's really saying is you're already designing an experiment whether you know it or not. DOE is just the tool to make sure you're designing a good one that actually gives you real answers. Okay, so to really get why DOE is so powerful, we have to learn to speak its language. So let's swap our baker's hat for an engineer's helmet for a minute. We're going to use the simple catapult to break down the core ideas. All right, first up we have what's called a factor. It's super simple, it's just an input variable that you have control over. So for our catapult, a really obvious factor is the launch angle. For our cookies, a factor was the amount of sugar or the oven temp. Then for every factor, you have levels. These are just the specific settings you choose to test. So for our catapult's angle, we could pick a low setting, and in the world of DOE, we often just call that a minus setting. Or we could pick a high setting, which we'd call a plus setting. This little plus and minus notation is going to become super important in a bit. And finally, there's the response. This is just the outcome, the thing you measure to see if your changes worked. For the catapult, the response is pretty obvious. How far did the thing fly? For the cookie, our response might be a taste score from 1 to 10. Okay, so we've got factors, levels, and responses. It seems like just a tidy way to organize things, right? But this is where DOE goes from being a neat little tool to an absolute powerhouse of discovery. We're about to talk about the secret sauce that the one thing at a time method almost always misses. We're talking about interaction. Let's jump back to our catapult. We can test the angle, right? And we find that a higher angle makes the projectile go further. Okay. And we can test the tension on the rubber band and find that higher tension also makes it go further. Great. But the million-dollar question, the one DOE forces you to ask, is this. What happens if you crank up both the angle and the tension to their highest levels at the exact same time? That right there is what we call an interaction. It's when the effect of one factor, like our angle, totally changes depending on the level of another factor, like the tension. To put it simply, it's when two things work together to create a result you just wouldn't expect. It's synergy. It's when 1 + 1 doesn't equal 2. It equals 3 or 4 or even 10. And that is where the breakthroughs live. And here's the really cool part. You can literally see an interaction on a graph. If you plot out your results and the lines are parallel, like a set of train tracks, it means your factors are independent. No interaction there. But if those lines cross or spread apart like dueling swords, you've hit the jackpot. You have just found an interaction, a hidden relationship between your variables. And when you find a positive interaction, it's like finding a secret cheat code in a video game. Maybe a high angle plus a high tension doesn't just add a few extra feet to your launch. Maybe it creates this massive, totally unexpected boost that sends the projectile twice as far as you'd ever predict. This is how you find those huge, game-changing improvements. But it can also work the other way. Check this out. This is a real-world example from a manufacturing process, and it shows a negative interaction perfectly. The two factors are machine speed and its setting. Now look at that top line. At one setting, making the machine go faster helps a little bit. But look at the other line. At that other setting, increasing the speed actually makes things worse. The lines cross, which is a giant red flag telling you these two factors are fighting each other. Without DOE, you could waste so much time trying to fix the speed when the real problem was the interaction. So, being a detective and finding these hidden relationships is pretty cool, for sure. But what's the actual payoff? Why does any of this matter outside of a factory or a science lab? Well, it boils down to three huge advantages. First is screening. Imagine you have 20 different things you could change in your cookie recipe. Instead of 20 slow, painful experiments, DOE lets you run just a handful to quickly find the 2 or 3 things that really matter. Second, there's modeling. You can actually create a mathematical formula, a true recipe for success that can predict the taste score for any combination, letting you find the absolute perfect recipe without endless trial and error. And third, verification. You can prove with data that your final recipe works perfectly every single time. So really, the true power of design of experiments is that it's a filter for complexity. It lets you cut through all the noise, all the trivial little things that don't really matter, and lets you focus all your time, your money, and your energy on the critical few things that will actually get you the result you want. So whether you're a scientist trying to cure a disease, a marketer trying to design the perfect ad, or just someone trying to bake the perfect cookie, thinking this way is a total game changer. It pushes you to look for those hidden connections, those secret synergies that are all around us. So the question I want to leave you with is this: what powerful hidden interactions might be waiting for you to discover in your world?